Hi, Physics 20s. I really do need to show you the second example on that friction practice sheet, and then hopefully the back side will make sense. So I want to focus in on this sled here, this 50 kilogram toboggan. There's something about drawing this free body diagram I failed to show you in earlier, and that is as you sketch the free body diagram, yes, you'll draw the force of gravity straight down. As you are learning, the normal force will be perpendicular to the surface, and the force of gravity perpendicular will be equal and opposite that. So as you start labeling this, there is one crucial detail I left out, and that is that this angle right here, this angle right there, is going to be exactly the same as this angle right here. And if you can kind of follow that just a little bit, if you can see that in this first triangle here, I'll maybe just sketch this once here. In this first triangle right here, with this, the first part here being 20, and then this part here would be a 90 degrees, then it makes this angle right here would have to be 70 degrees. Remember, all the angles have to add up to 180 degrees inside a triangle. And so that means, though, then that this part right here is going to be 20 degrees. Because if you can see, all of this makes up all of this area in here, this area all in here, that's going to make up 90 degrees because it's perpendicular to the incline. And so the 70 here plus the 20 right there gives us or confirms that that angle is 20. So I'm going to back all that out of here though, because I just wanted you to see that that angle was 20 degrees. Okay, so effectively what that helps us do is solve for the components of this the force of gravity triangle. And to get started with that, the easiest one you can always start with is the force of gravity. So the force of gravity in this case would be m times g. I won't rewrite that, but it's 50 kilograms times 9.81 meters per second squared. So for now, that's 490.5 newtons. Now, I'm not going to round anything yet. You shouldn't either as you get going. So if you know the hypotenuse as 490, then you're going to just find, that's newtons, you're going to find the adjacent and opposite sides. And again, if this angle in here is 20 degrees, then it would just be a simple matter. If I did the cosine of 20 degrees times that 490, okay, then that winds up being 460.919 newtons. And that would be equal to the force of gravity perpendicular, okay, because I found the adjacent side to that angle. And then I would do sine of 20 times 490.5, and that would give me 167. And that would equal the force of gravity parallel. Now, in most of these questions, you're going to need to find both, and then or it won't hurt you to find both, and then you're going to use one of them to determine either the coefficient or something else. So actually in this question, I didn't even read it, but it does say calculate the coefficient of static friction for the toboggan on the snow. So here, I'll just make some room here because I know I did all of that. So we can calculate the coefficient by referring back to the formula for static friction. In this case, for static friction, it'd be FF static, is how I think I wrote it on the formula sheet. And in this case, it just begins to slide again. Remember that vocabulary from before. So if it just begins to slide, it means you just reach the maximum static. And so for maximum static, some students even put the word max under here, but that's a lot of subscripts. The force of friction static maximum will equal the coefficient times the normal force. And so effectively, we never have a formula for the normal force, but we know that it's going to be equal and opposite of the force of gravity perpendicular, which we already calculated. So, and the other thing is that the force of gravity parallel downhill, that's going to be equal and opposite the force of gravity, or sorry, the force of friction static uphill. So this actually means we can write this formula a bit differently, and I'll just highlight that here. We can write it as the force of gravity parallel has to equal the coefficient of static friction multiplied by the force of gravity perpendicular. See, because the normal force is equal and opposite of the force of gravity perpendicular, and the force of static friction in this case is going to be equal but opposite of the force of gravity parallel. Sorry, I wrote that as an 11. It really should be like, you know, like sideways, two like forward slashes or something to represent parallel. That's really what the symbol represents. So in this case, then we can just divide the right-hand side by the force of gravity perpendicular, and boom, now we have a formula for the coefficient of static friction. And you'll see this on your formula sheet. It's a bit of a shortcut. It just says a general mu is equal to the force of gravity parallel divided by the force of gravity perpendicular. This is why coefficients have no units, because look what we did right here. I know I deleted those numbers, but what it is that it was 167.761 newtons was the force of gravity parallel, and the force of gravity perpendicular was 919. And if you crunch that through, we have to round it to two significant digits because of the numbers. You see them there. The answer is 0.36. And as you can see, the newtons cancel. So there's newtons on the top, newtons on the bottom. There's no units. So this is why coefficients don't have any units. Anyway, I hope that's helpful. I will post the answers to the other questions momentarily, but thank you.